Okay, on to question 4. We've got a very simple question here in terms of converting a binary number into hex. This is very easy once you know how to do it. We've got to remember that we've got the hexadecimal numbers, which I'm going to write down the side. So we've got 0. Oh, I'm in the wrong colour. Let's rub that out. Thank you. So I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. 0 being equal to 0 in normal numbers and F being equal to 15. So what we need to do is we need to split this into 2 parts. So 1 and 2. So we've got 1, 0, 0, 1 and 1, 1, 0, 1. Now we can put the binary headings along both of these, so that would be 1, 2, 4 and 8. 1, 2, 4 and 8. 8 and 1, because it's got a 1 underneath, will be 9. And 8, 4 and 1 comes to 13. So 10, 11, 12, 13, D. So the answer is 9D. Very simple. Now, what you can do for the second question in terms of the denary equivalent is you can either do the whole number 1001 1101 and put in the binary headings again 1, 2, 4, 8, 16, 32, 64, 128, and then add those up, which comes to 157. Or you can take your 9D and do 9 times 16, because hexadecimal is base 16, and then D, which is 13, times 1. Add that up, and you will come to 157. So, simple as that, really. These things you can practice. Remember, there's the quiz on Moodle to help you with hexadecimal conversions. Practice on there and you will quickly get good at this and never ever lose marks in it again. Quite a number of people do this well. Now the question is why programs use hexadecimal. Hexadecimal directly represents binary. We can see this up here in that we have little groups of 4 bits, or a nibble as it's sometimes called, gets translated to one hexadecimal digit. So it preserves the relationship with binary, whereas denary doesn't. The second thing is that it's more compact to look at, so it's easier for a human to interpret. So easier for human to read than binary, very important, the second part. Okay, and then simple to convert to binary gets you the expansion for the full 2 marks. Going on to the next part of question 4. Main memory stores data and instructions. We should know this from the Little Man computer, where we have got the diagram over here with our registers, and then we've got the main RAM over here, and the program is stored in these cells up here like this, and it could also write to memory location cells in there. So what you've got is data and instructions sharing the same memory space. 4.5. Computers computers also store data in secondary storage. Describe the role of secondary storage in a computer system using an example. So I was looking for several things here. So secondary storage is non-volatile. So that means does not lose data when powered off. The second thing I was looking for is it is the permanent store of data. And then the last thing was I asked you to use an example. So you could say, for example, a hard disk stores files and programs. Equally, instead of hard disk, you could have said USB stick, or you could have said an optical drive, or CD-ROM, or DVD. That would have been absolutely fine. So that concludes question 4.